today I want to try something. So since it will take a bit to complete one of the steps that I want to share, for some part I recorded and we can skip the slow bootstrap of the VMs and so on. But for this one, I like to tease with some command that we will come to it later. So just take it like, okay, here I'm applying an Helm chart of some software. Just believe me and see how it proceeds. And this software is going to create, I'm in a Kubernetes cluster, and I have a node, a mysterious node that is not ready. Okay. And then I'm going to launch this simple Dagger command that is using the module that we are going to see in detail in a minute. So bear with me a second. Let me just type create start. Okay, and we'll leave this working while we are speaking. So coming back to presentation that I prepared just to introduce the topics. Well, the application, the module that I'm going to show is basically for two main case studies in mind. I hope you can see it, otherwise I can zoom in, I suppose. Well, the first one is okay. I have a machine learning pipeline of some sort on my continuous integration, and I want to delegate part of this job to an external machine that maybe has multiple GPUs or whatever. And on a slightly different pattern, there is a more standalone application of this module that is, okay, I can compose this module with something else, creating a multi-step setup for my infrastructure. So for instance, we are going to see in practice, I have a framework for developing AI application that works like an hub plus runners. I can decide, okay, I want an easy command, just one command, to bring up on demand a runner, so a virtual machine with a GPU that attached to my framework in a seamless way. So I have one command, I run, and it is attached to my framework, so I can use this to make inference for any kind of AI stuff. And the other part is I want to do the same, but right now I'm not on top of a framework already established. I have a Kubernetes cluster, so I want an on-demand Kubernetes GPU node to be attached. So this is a technology that we use a lot for different topics in my institution and in our project where we participate, and we are evaluating this. So I work for INFN, as I mentioned. Maybe I didn't mention before, but I'm mentioning that right now. And this is the tool. We are not going into any details for time reasons, but yeah, we will see that the node that was stuck before, immediately after my module works and finish its work, will appear to be ready, and you can submit this stuff to an external VM. So two main topics: CI/CD for machine learning AI, where I want to spawn and delegate some task to an external VM, or complex setup for either attaching GPUs to a GenAI framework or to attaching a GPU to a Kubernetes cluster. So, okay, what these two use cases have in common? Well, both of them can be summarized. Allow me to summarize them as here. So start doing some stuff. This is the pipeline from the top to the bottom. So do some stuff, use my GPU wherever it is, and then get results and do some other local stuff. This looks like quite a good fit for a module, a generic module that I built on top of a particular provider, but it can be abstracted if you wish. So, and in this step in the middle, you probably want to create a VM, set up some dependencies, or import some data, and then execute a task. And yeah, here is end the task, not execute. Sorry for a typo. So 4 steps in my module that can be reused anytime you want into your pipeline. To be more specific, what we are going to do is, okay, I take a marketplace, and in this case, for my convenience for the API that they expose, I use Shadeform AI, a marketplace where you can see different providers with different price for VM on GPUs, and decide to spawn on one or the other. And then you have the other component that is, okay, I want something that is modular, programmable for pipelines and CI. So without any surprise, you can imagine that we are going to use Dagger modules. And eventually, how I imagine a typical workflow and why I decided for this kind of execution machinery. So the idea is, okay, once I have a module that is capable of creating VM, doing any kind of stuff, and delete the VM, I can create any sort of deck where different steps can be executed locally and bring data into my remote VM, and then get the result back. All of this in a programmatical way, combining different modules. And yeah, so just one thing, this execute task can be a simple bash script to execute any kind of operation in Python, or you can execute container like we are going to do for the GenAI part. And also you can use any kind of installation script to bring up custom components. And this is what we are going to do with Interlink use case. So we are going to download binaries, configure them, and make them run as daemons. Okay, if there are no questions so far, I'll proceed.
I have a quick question on in terms of when you're thinking about building this module for people who maybe new to Dagger. How long did it take you to think about, hey, this could be a perfect module to set up all these use cases, to set up this full use case?
So you mean how it looks this module, or where to start for?
So I think if you go back to the last slide where you're talking about, or actually the slide's perfect, that's what your module is going to do. I was just trying to think of if a new user was thinking about, I wonder what module to build. Like this one's doing a lot of things. I was just wondering, like, if it took you some planning time or how you approached figuring out if this would be the best module to build for this use case.
Yeah, one thing that I consider for the module is how generic it can be. And it was actually a question that I had also before related to the Fly.io module. So the idea is that you can abstract this kind of procedure whatever provider you use. So I'm using Shadeform here, but I can use any other kind of provider with the same logic. So I can reuse this very same schema in different places. Also, yeah, and also the other part is, okay, I want the module to be as single target as possible. So as the simplest it is, the more you can reuse in general. So this is at least my experience. So you will see that in this module, I will use another small module for templating that is really simple, but you can reuse in different situations. So yeah, it's kind of splitting a monolithic DAG in different micro DAG.
Okay. Awesome. So like, if your advice probably to people who are watching or haven't got started is really think about the building blocks and the reusability. And then from there, then build that first module that you think might have the most reuse capabilities.
Yeah, definitely. I think the reusability should be, it's central to me. And also, yeah, I have other consideration that we'll see looking at this module. So yeah,
Awesome.
I don't know if others have any other comment on this, but
Thanks,
I have a
Ethan.
question. I'll keep it for later. I'm curious to see the code first.
all right. So yeah, you can find, first of all, you can find the module in Daggerverse if you look for Shadeform, and you have some more complex end-to-end example on how to use this combined with a real-world installation. That is the one that I launched at the beginning of the demo. And then you have a more simple command like you want to remove the VM or do some other fancy stuff. It's written in Python, so you will see the example in Python, and it's pretty simple, so we can go through directly. You see it correctly? Okay. Yeah, it's readable. Yeah. Okay. So how a module looks like. It's start everything from a class where you can set up some environment, and we will see later this in practice. What you need usually is defining your deployment with a name and a shade token for the authentication. All the rest are utilities. In particular, the cache one is responsible to store the information of the virtual machine you created to avoid, for instance, that you create a VM twice and then you forget to remove. That's kind of, that would be painful to forget some VM with 8 H100 running in the background. And so the first command is, of course, creating my VM. And I can pass loads of variables. Here you can see the name, shade token again, the ID of the VM if I wish, and different kind of information. But again, this is the instantiation of my module. Okay, so you can consider this the init function of your module. So here you can define different kind of logic for initiating different kind of global, if you wish, namespaces. So I decided to use this init function to create a cache module for each deployment name. So I'm sure that whenever I call different function with this name, I'm referring every time to the same VM. I cannot make mistakes. Then I create some other utilities modules. This is the client one, so the one responsible to mount the cache and do different commands. So, and also another utility is checking if the VM already exists. This last utility is used directly into the first real function, the one that you can actually use, that is create the VM. So when I create the VM, I ask you for different parameters, which cloud you want to spawn it, region, instance type, shade cloud, etc. And this is parsed directly into this dictionary. And then there is the utility script that I defined before that check for, it's quick and dirty. Don't be crazy on the Python style or Pythonistic function and use, but yeah, it works, and for demonstrating it's quite complete. So I'm checking here that the ID of the VM doesn't exist, and if so, I can create it without any issue. So going ahead, I take my client and I use a Dagger template module. So this Dagger template is another module that, if you go here, Dagger template, I don't remember how it's called here. So it's a simple module that takes a JSON string with all your parameters and a template file, a Jinja2 template file, and they compile it and mount a file into your chain. So I'm using this because I'm creating a template file for the deployment in Shadeform. And with this information that you pass, this template will be built and put into data.json. This information then are used to create your VM with a curl using all the APIs. So you see, it's pretty rough if you want, but you can do these kind of things. You can chain any kind of exec and files in your containers and do all the most fancy thing that you can imagine. And in this case, I do the curl, I save the output, I parse the output to store any kind of information I need. And eventually, I go back and return a container. I go quick to all the other function. This was the most interesting one. There are others that are okay. Once you create a machine, now you have in your cache all the information. Give me the VM ID, give me the information of the VM, and get the available VMs and the available providers for this kind of GPU. You can list and take the cheapest one, and also get the VM status. That is quite important, of course, because you want to wait for the VM to be ready to do any kind of other operation. Get VM users. Okay, these are information that are useful because you want to also operate on this VM from remote. So you want to SSH and do commands or load files. VM ready to check and to pull a Shadeform to understand when the machine is ready, and create and check combine the create VM and the VM ready function inside. I want also to delete my VM. I want to execute command on SSH, gathering all the information I need from other functions. So you can see that in this class, I have different functions that are utility functions, like these ones, and some other functions that I call more core function because are the one that you want to actually expose and use in a daily life if you want. So you want also to copy file, you want to copy directory, and so on and so forth. There are plenty of other stuff that you might want to do and you can add to this module. But yeah, this is the core implementation that I have at the moment, and we are going to look how it works. So for the basic functionalities, I have a video, as I mentioned before. So if there are comments or questions, I think we can take some, and then I'll show you how it works in practice. Yeah.
The main question I have is there an opportunity later? This is like a Dagger wrap, like you're wrapping a pretty complex but powerful system in a Dagger API, right? And it abstracts away creating and running VMs, and then inside of those VMs running specialized tools. Is there an opportunity later to make this a Dagger sandwich where it's Dagger on the outside and then some VM and tooling, but it looks like the work that the tooling itself does inside the VM possibly could be Daggerized also? Is that something you're thinking about? Like Dagger to VM to more Dagger?
Yeah, possibly. Yes, it's an option. Unfortunately, I think that in that case, you will lose the possibility to access directly to the GPUs. So that's it's what is blocking from make a Dagger inception.
Oh, I see. Sure. We should try. It would be interesting to see if we can use the. There's a GPU-enabled build of the Dagger engine. I don't think it's in the default yet, but there's an experimental API where you can say container.with GPU, and then you can get a container with a GPU, mounted inside. But I think there's some asterisk. I think it's NVIDIA only, and I think that's actually the main asterisk. Like it doesn't work on my Mac, sadly. And it doesn't work on other hardware than NVIDIA. But I think it might. I'd be curious to see if it helps in your scenario on NVIDIA hardware. Yeah, I feel like we should advertise that feature more. I don't think people know you can run Dagger with GPU access if the stars align. Like, were you aware of that feature, Diego, or are you just learning it now? I'm curious because we don't really talk about it.
Now that you said, I remember that I asked for that and you answered exactly like this, but I never tried because
yeah, I mean, it's somewhere, it's kind of in a corner. We don't exactly put it in your face like, hey, try the GPU feature, but yes, there's a lot of potential there.
Yeah, also because
now Pal's making
the
a module.
the script that I started before the demo is essentially quite a long script. You can see quite long. It's a series of steps that can be very well Daggerized, I think. So it could be cool. Yeah.
Oh, also I had a much smaller question, but I noticed in one of the functions, you do a lot of work, and then at the end you return an empty container. And I don't know if anyone else caught
this
that.
is because I'm a physicist. I love to do. No.
Did anyone else see that, or did I maybe I
listened?
Yeah, that one.
Because I'm returning this if everything went well, and then I can return anything if not. So
I see.
Yeah, I'm checking if this fails. It means that the VM it doesn't exist, so you can go ahead and creating one.
I see. It's like a Python thing. You the function has it returns a container type, so you have to return something at the end that's a container.
Yeah, I don't know if there is an option to do something like container or known.
I guess you could just raise an exception. If you get there, it's probably an error, right? You probably just want to raise an error. But okay, I see.
Yeah,
it's like
error. I don't
basically it's not. You're not supposed to get to that point. Basically, okay, I understand now. Sorry, I had to know. I was curious.
Sure.
And there's a comment about the GPU enabled that Patrick was mentioning. It seems interesting since the ML models are faster. But if moving on to this, if someone's watching and they want to like try it out or learn more about it, where would be the best place to do? Or Kyle, maybe you both know.
To learn about what? About the GPU?
Feature? The feature.
That's a good question. I don't even know if it's in the docs. It's maybe in the cookbook.
Okay.
I think in doubt, Discord. Discord and like the hive mind. Ask the hive mind. I want to do GPU. How do I do GPU?
Okay, perfect.
But, the short version is I think you need to install an alternative version of the engine. I realize now saying it, we should really make this easier. It's not really it's like an advanced thing. We should just we've had some challenges in combining those two builds because the basic, like the standard Dagger engine is built in a container that's on an Alpine base, nice and simple, nice and small, but it doesn't have NVIDIA compatibility. It doesn't have the NVIDIA libraries.
Got it.
And the Ubuntu does, but Ubuntu is bigger, and we've been hesitating to just swap in Ubuntu, making everyone's downloads bigger, basically. So that's why it's an alternative build. But yeah, join Discord. Say the magic word GPU 3 times. GPU. And then we'll set it up together.
Awesome. Okay, sounds good. We'll make a community call to-do list. We have some modules to make. We have some documentation to write.
Yeah.
Awesome. All right, Diego, sorry to interrupt. Go ahead.
No problem. So I think it's time to see it in practice. It can be clearer, I think. So let me start the video. As I mentioned before, I accelerated it because it could take some time. So, okay, I am logging into Shadeform. I'm deciding whether I want to set up things in different providers. HyperStack is the one that is by default in the module. So I can call it I can call my module directly like, okay, name and sheet token, that are the parameters that I put that are fundamental for instantiating everything. And then I use the default value of create and check function. So by default, we'll go on with a GPU A7000 and A6000 and on Hyperstack, if I remember correctly. So yeah, it will do some VM by default. Ideally, I have in the plans to make by default launching the cheapest VM on the marketplace. So that could be a nice feature to add. And you can see that, okay, everything is working, starting to create the VM with all the with the requested instance type. Once done, it's polling. You see different tries. It's polling for the status. Whenever it is done, of course, is not the fast I accelerated it. It can take 5 to 10 minutes. You have the active status on your right-hand side, and eventually the module discovered that the ID for this deployment is this one, and they show you the ID. I can retrieve different kind of information now from the cache, so I can tell get VM ID, and the module will retrieve the ID of the VM. And then I can ask also different kind of things. You can see here all the function. And for instance, I can run an SSH command. Exactly. Passing my SSH key and asking for, okay, execute on the remote VM NVIDIA SMI, so I can list the GPUs available on this host. And okay, everything goes ahead, retrieve all the information on the user and SSH endpoint, and eventually it prints out the results of your command. So you have everything in hand to interact with this kind of VMs, and also to remove it. So you can go ahead, do the delete VM, and the VM will be eventually removed from the right-hand side. So I don't recall why this error, but okay, the results is good. You have no more instance available. And a tiny, more complex example is the one that I mentioned before. So I don't know how many of you know Alex, but this is an example of application where you have, okay, let me go back to the presentation, sorry, where you deploy on your Kubernetes cluster an app that exposes an endpoint, and then you can spawn everywhere, basically, Docker containers or containers in general that connect back to this hub through a WebSocket with a particular token. And in this way, you can have on-demand GenAI inference VMs and use them as they come. So in the very same way, I can combine. Okay, you see here I have my ChatGPT like menu where I store all my session or my questions, and this one is the dashboard. Here on the right-hand side, you see an empty space that is the one related to listing all the connected runners. So we start with 0 runner on this instance, and then I collected different codes, combined codes of this module into NSH. The create one, so the create command here will basically do, you see in a second, will execute the create and check VM on the very same infrastructure as you see here where I have my cursor. So again, this is pretty simple create VM that we saw before, and you see again here is creating my VM. After some time, this will succeed, and now you have a second step that is available, that is this one. So let me stop here. The start command will execute an SSH command with all the needed information to connect back to the hub. The token is changed, so I can show it to you. And all right, so let's start our runner that will download the image on the remote host. So you can see here we are not really using the Dagger to run on a automatic CI, but more like wrapping command for setting up stuff. And of course, for GenAI platform can be not so useful, or maybe you can find some use case for this, but especially useful for the thing that we launched before. So you can imagine that you want to add a Kubernetes node just in particular situation, you can automatize the creation of a VM and attach back to your cluster. Okay, so everything runs, and voila. On the right-hand side, you see the runner running on Shadeform that is attached to my GenAI platform. Now I can go ahead and say, okay, hi. And after some time, the bootstrap for the first question is not lightning fast, but it gets faster the second time you ask. So you see here the inference is taking place. We are warming up. And as soon as completed, right now, you will see the answer appearing in your platform. So you're using on-demand VM to do GenAI inference in this case. You delete the VM, you pay only for the small amount of time that we use this example, and you're good. That's one of the applications that you can use. And on the very similar behavior, let's see if what we launched before succeeded. So we can go back here, and you can see that eventually, as soon as my instantiation of the service is completed on the remote side, I have my remote node that now is ready. So if we do describe node, and this is the thanks to the magic, if you want, of the interlink software that I showed you before. But you see, let me increase the size. Okay, and you can see that we have a GPU available and some kind of CPU and memory at our disposal to schedule pod on this kind of node. So yeah, you can do all this kind of stuff. One thing that I want to mention, just concluding, is that now I'm installed components, but this can be also one-shot execution of any PyTorch training code that you want to run once and shut down your machine. So this kind of approach, you can reuse this module in a pipeline that import your data on your machine, do the execution, store your data somewhere else, close the machine, and go ahead with your pipeline. This is something I want to also investigate, and I did some tests with some preliminary tests with simple commands. Kind of, if you wish, a Dagger flow would be kind of cool. So yeah.